Hi, everybody. This Edpuzzle will review some learning theories and how they're related to technology, and then also some learning frameworks that aren't really theories, but frameworks that we'll refer to in helping us kind of think through technology and education. So we'll start by just reviewing the two primary learning theories, which are on two kind of ends of a spectrum. We have behaviorism on one end and constructivism on the other end. You probably have heard of these, in 101 or in some of your other classes. And these are important to keep in mind because you want to be able to use these terms in the future for TPA and for your other exams. So I think it's helpful to review them now and kind of how they relate to technology. So first we have behaviorism, which is that knowledge is transmitted and acquired externally. So the teacher gives knowledge, that you can shape student behavior to help them learn by giving them a positive reinforcement or a negative reinforcement. So this B.F. Skinner is the main theorist in behaviorism, and he said that people have voluntary mental control over their responses, and the consequences of past actions can act as a stimuli to shape future behaviors. So that's stimulus, response, reinforcement. This is where teacher asks a question, student responds, and the teacher says, good job. Or the student responds incorrectly and the teacher would say, no, that's not right. So a behaviorist instructional model, what you might see in a classroom that's behaviorist, is direct instruction. So standing and delivering, you can tell a student something and they will learn it in that way. It's teacher-centered. There's a lot of individual work. This is more of a traditional teaching method. So, this might be skill worksheets where there's a correct answer or a test with a correct answer. So you would then mark the test yes or no, rather than kind of a more constructive, creative response that takes a different kind of assessment. So there are technologies that support some of this more rote type of learning that is sometimes necessary in schools, and that would be skill practice tools. Like there are many quiz tools that I'll show you at least one to give you an idea. Flashcard tools, there's also games, and adaptive tools where you get the right answer and it'll give you a harder or easier question the next time around. And then simple presentation tools like a simple PowerPoint is also sort of a behaviorist tool. And then on the other end of the spectrum, we have constructivism, which is, the belief that knowledge, it can't just be given by the teacher to the student. It has to be constructed by the individual. So students come to you with all sorts of ideas about how the world works. And so you kind of have to help them fit the old ideas in with the new ideas. And students have to do that in community, and they have to do that by doing, right, in the classroom. So this is kind of a newer way to think about how to transmit knowledge. Some of the thinkers are Dewey. Vygotsky is about zone of proximal development and that social constructivism, where students can learn more alongside a more capable peer or a teacher. Bruner was discovery learning. Piaget was assimilation and accommodation, which is the idea that I just said, that they come with ideas and they have to kind of take the new ones and figure out how they work with their old ideas. And sometimes they get rid of some of the old ideas, or sometimes they modify. And it's just really that idea that kids aren't really little blank slates, right? They have to assimilate that knowledge into what they already know about the world. And then Levin Wenger, another two thinkers, they use the term community of practice, and just it's the idea again that students should learn. They need to learn together with others while doing whatever they're trying to learn. Some constructivist instructional models, these are student-centered. It's about group work and cooperative learning. Inquiry-based instruction is, pursuing a question and trying to figure out the answer and the learning that occurs that way. Project and problem-based learning, again, it's around creating something and the knowledge that comes with that, or figuring out something and the knowledge that comes along with that. So it's really focused on higher level thinking. Some useful technologies for constructivism, collaborative writing tools, productivity tools, so any of those things that can help you be productive, like different types of multimedia. So creating a video or creating a website that teaches, or even social media and the interactions that occur there. So some frameworks for technology integration are, first, TPACK. which is something that you should have read about. This is the TPACK, stands for technological, pedagogical, and content knowledge. So the idea here is that when you're using technology in education, you really need to be thinking about three things. Number one, what technology should be used in this situation? What makes the most sense? Number two, what is the content I'm trying to teach? And do I understand the content I'm trying to teach and how that technology works together with that content? And then pedagogical knowledge, which is how do I teach that content? And does this technology make sense and support the way that I would teach that content? So, I am not an advocate for using technology all the time, no matter what. I'm an advocate for using technology when it's appropriate for what you're teaching. Is it appropriate for language arts, for example? And when it's appropriate for that level of student, and the proper way to teach that content. So let me give you an example. I taught middle school science, so this is an example in middle school science. So the technological knowledge is what we are learning in this class. So the tools, the broad tools available to teach using technology and how they work, right? So you need to have that. And then the content knowledge in science, or the skills and content of science. So in science, we have skills like observing, inferring, measuring, classifying, predicting, communicating. And then we also have life science, physical science, earth and space science. Those are all the sciences taught in middle school. And in between there are how those two things interact, the technological content knowledge. So which technologies are appropriate for science? So here we have tools of science, microscopes, telescopes, sensors, measurement devices, tools for analysis, tools to communicate, algorithms, etc. Then we have pedagogical knowledge, which is how to teach science. And in science, we teach using constructivism, typically. Inquiry-based is the most common. So let's look at the cross between technological knowledge and pedagogical. So how are we teaching with the technologies? So we think about the fact that we can have a global audience in order to help students construct knowledge, right? So now we can create websites, we can have pen pals across the world, and we can share that knowledge that we're learning in science with them using the tools that we have. It's multimodal. Some of these technologies are multimodal that help students to present their knowledge in different ways. They might create a video to show what they know rather than having to write pen to paper and that's it. It gives students some more control, maybe having options in how they present their knowledge or how they get to understand and interact with the knowledge that you're presenting. And then also extending the time and space of school. So, students are constructing their own knowledge and they might go back to their learning management system like Canvas to continue the discussion that was going on during class. And that's kind of new technology that supports good pedagogy. And then lastly, how do content, so the content of science, how does that cross with pedagogical knowledge, or how we should properly teach science? Well, this is how to teach science. So in science, we should use inquiry strategies like the learning cycle, problem-based learning, etc. So you want to be thinking when you're using technology, how, what your content is you need to teach, what's the best way to teach it, and how technology interacts with both of those things. If the technology is not a good fit, then you shouldn't be using it. The next framework is the SAMR model, which stands for substitution, augmentation, modification, and redefinition. And this is really a framework to help teachers kind of think through what they're doing with technology. So are they using technology really to transform their teaching, or are they using technology kind of as a replacement for what they were doing already? And so is technology being as impactful as it could be? So, none of these are bad, but it kind of goes up the scale on Bloom's taxonomy to kind of more complex uses. So substitution is the tech acts as a direct tool substitute with no functional change. Augmentation is it acts as a tool substitute, but there's some improvement, and that's enhancing the curriculum with technology. And then we have over here transforming, which is modification. The technology allows for significant task redesign. And then finally is redefinition. The technology allows for the creation of new tasks previously inconceivable. So let's take a moment to see what that means.
Every day, teachers are designing activities to target higher order thinking skills in order to engage students in rich learning experiences. But integrating technology adds a whole new layer to teaching and learning. How can technology transform your learning design? Dr. Ruben Puentedura developed the SAMR model as a way for teachers to evaluate how they are incorporating technology into their instructional practice. You can use SAMR to reflect upon how you are integrating technology into your classroom. Is it an act of substitution, augmentation, modification, or redefinition? Dr. Puentedura likens his model to moving up a ladder. The model includes a dotted line that represents the threshold where you shift from using technology to enhance learning to using it to transform learning. Transforming learning promotes higher order thinking skills, such as analyzing, evaluating, and creating, which are essential to Common Core state standards and 21st century learning. So, how can you teach above the line? Let's take a look at an example of a classroom task and how it evolves through the lens of SAMR. In substitution, technology acts as a direct tool substitute with no real functional change to the task. For example, take creative writing. What if you had students write a story using a word processing program? In this case, students are substituting a handwritten story for a typed story. The task is the same with no real change in student engagement. In augmentation, technology still substitutes, but with some functional improvement. What if you took the same creative writing assignment and had students use a word processing program? They could use features such as spell check and tools for formatting. Again, the story writing task is the same, but the technology augments it with enhanced productivity. In modification, technology should allow for significant task redesign. Take the same creative writing assignment and have students use Google Docs to write their stories. Students can then share these stories with peers and provide real-time feedback. Here, technology has significantly modified the original task by introducing the benefits of student collaboration. At the top stage, redefinition, technology allows for the creation of entirely new tasks that were previously inconceivable. What if students transform their written stories into multimedia productions? After creating storyboards, students film scenes, edit clips, and add music. They can publish the videos and receive feedback from voices across the globe. In this case, technology redefines the story writing task to include media creation, critical thinking, collaboration, and communication. So, how can you use SAMR to reflect upon transforming your learning design? Puentedura offers reflection questions to help you move up the SAMR ladder and shift how you are designing learning experiences. For instance, ask yourself, what will I gain by replacing the older technology with the new technology? Have I added an improvement to the task process that could not be accomplished with the older technology at a fundamental level? Does this modification fundamentally depend upon the new technology? How is the new task uniquely made possible by the new technology? These are just a few of the questions you can ask yourself as you evaluate the design of a classroom task, and consider that not all technology integration is created equal. Ultimately, SAMR can help you evaluate your use of technology and design tasks that target higher order thinking skills, engage students in rich learning experiences, and impact student achievement.
Okay, so that's a little bit more on SAMR. And the final framework that I want, oh, actually there's two more. First is universal design for learning. And so universal design for learning is this idea that we should really provide multiple means of representation or multiple ways of presenting information to students. We should also provide multiple ways for students to express what they know and multiple ways to stimulate interest and motivation. So this is important because students are all different, and these principles came out of special education. So we should really be thinking about the fact that all of our students aren't the same and deciding how we can present information to them differently and allow them to present what they know to us differently. So that's called universal